There we go. Thank you so much for joining us today for a really exciting CDRN session. We're going to be speaking today about cross-border hazard, risk, and risk management across the Caucasus. And we're thrilled to have two fabulous speakers here with us today. So we have Nina Shatberashvili, who is the Director of Sustainable Caucasus, and she'll be speaking to us a little bit about her work. And then we have Richard Walker, who is a professor in earth sciences at the University of Oxford. And he's going to be talking to us a little bit about his work in identifying and studying active faults across the region. So a huge thank you to everyone who's joined. And without further ado, I will pass the mic over. Nina and Richard, we didn't actually establish, but I'm happy for either of you to go first. So whoever wants to jump in. Nina, unfortunately, you're muted.
Probably I prefer to be second.
Okay, great.
Okay.
Richard, if you're okay first, thank you.
Okay, I do have some slides, Ainsley, so I'm just going to get this up. So that should be there. Let me just start the slideshow. Okay, so thank you very much for the invitation. It's a great pleasure to be speaking to you all today. And as Ainsley was describing, we've been working mainly on earthquake hazards in the Caucasus regions as part of a larger program working in many areas, also further east into Central Asia. And what I'm aiming to do today is to talk through some of the methods that we're using. So I talked through the basics of what is called here paleoseismology, right? This is essentially digging excavations across active fault zones and learning from them what the past records of earthquakes are upon them, right? And this can be historical period, it can be prehistoric period. These are the timescales that actually end up being the key timescales in order to try and understand earthquake hazards, right? So, you know, long recurrence intervals, long gaps in any one place between earthquakes, but we need to go further back in time in order to be able to do this. So this is a collaboration between various colleagues in the UK, in Azerbaijan, also in Turkmenistan. And I'm going to start off, well, first of all, after I've given this introduction, I'm going to start off by talking through some examples from Turkmenistan. And the reason why is, one, we've actually kind of got quite far into the project there. And so it's a good demonstration of what we can do, but also it's all kind of tied together in terms of, you know, this whole region. We've been looking both to the east of the Caspian Sea, to the west of the Caspian Sea. So why do we do this kind of study? Well, it's a way of assessing whether faults are active or not, whether they constitute zones of earthquake hazard, rather than just waiting for earthquakes to occur in any one place, which can be hundreds or indeed thousands of years in between. Instead, we can go back in time and we can establish these activities or not. It's useful also from a purely geological sense. Learning about how the Earth works, learning where active faults are, how they accommodate overall tectonic motions. But for this kind of talk, it's one of the key tools in terms of understanding the earthquake hazard. The region we're talking about here is set up in the northwestern part of these maps. The left-hand side here represents earthquakes that have occurred both historically in red dots, right? These are from the Ambroses and Melville catalogue of earthquakes in Iran, and white dots, which represent instrumentally recorded earthquakes from the 1960s onwards. On the right-hand side, we have a similar map, but here the white dots represent earthquakes that have killed more than 10,000 people, and in red those that have killed more than 30,000. And you can represent, if we look at the earthquakes that have had a major societal impact, those that have killed many people, you can see that the Caucasus region is in no way insignificant. Shamaki has experienced a number of destructive earthquakes, the most recent in 1903. If we look at the historical catalogues of earthquakes, you can see that actually there's quite a number in instrumental times, but very few in terms of historical catalogues. And so there's immediately a question there. What does that tell us, right? You know, the fact that we're missing seemingly a sufficient number of historical earthquakes across the regions. We know the ones in Shamaki, we know the large Ganja earthquake in the 12th century, etc. But you know, overall, we possibly should have more. Does that mean that the historical records are missing? You know, does it tell us the faults are behaving in different ways and not producing large earthquakes? So these are all questions that paleoseismology can answer for us. We have started, you know, the overall project. We actually started working in the east of the Caspian Sea. So we've been looking also regionally at, you know, how the Caspian Sea behaves. What's it actually doing? What are the tectonics of the Caspian Sea? And if we zoom in on Turkmenistan, and this little circle has appeared there, you notice things here. There's a big gap in seismicity, right, in historical recent activity. All the way along the edge of the Kopet Dağ Mountains, these ones here. And so again, we can start to assess using paleoseismology. What does that mean, right? Is that an actual gap? Does that mean there's low earthquake hazard, or does it mean we've missed something? Can we establish this from the kind of techniques that we're looking at? If we look at that Turkmenistan region, right, we have there's kind of a plate tectonic story. The Caspian Sea here has got one big fault along its northeastern edge, the main Kopet Dağ fault or Ashgabat fault. It's also got a boundary along the southeastern side in northeast Iran, the eastern Alborz, and those two boundaries are basically big strike slip faults, right? They accommodate relative motion. The Caspian Sea is kind of popping out off to the northwest at some rate, relative to everything to the east of it, and most of that motion is occurring on those two red lines that I've shown there. We've got a tectonic issue question. We can look at how fast, what direction, for how long have those motions been occurring for. But then also in terms of the hazards, these are very long faults, potentially very rapid slip rates upon them. And that can mean that there could be large earthquakes, right? So the longer the fault, the more slip can accumulate on them before they break. A gap in seismicity could mean that, you know, it could mean actually that there's a long gap between earthquakes, but when they occur, they're very large. And just to mention as well that we kind of see this behavior in northeast Iran. There is a record in 856, a very large earthquake, magnitude 7.9 estimated. This was the Damgan or Kumis earthquake, which was one of the most devastating earthquakes in history, with estimated death toll of about 250,000 people. So again, it's very important to see what this gap here means in Turkmenistan. If we actually go to Turkmenistan and we look at that main Kopet Dağ fault, we see that the fault is clearly active. We see it in the landscape. It's this line that cuts across the image here. All of these streams seem to show a deflection laterally across it, representing strike slip, right lateral strike slip. We can look along the fault, and again, it's very clearly expressed. It's this line here separating these small hills to the right from the lower parts to the left. If we look at it from a satellite image, we can see the fault very clearly. It goes all the way from the top right down to the bottom left. It displaces the landscape all the way across it. And in fact, you can see here this apparent offset of a river valley. That's very, very clear because there's actually a motorway running down this. So it looks so clear because you're looking at the road surface. But it is a river valley. And that river valley there is displaced, right? So you can imagine you can join up this part of the river with this part of the river. And we can measure the amount of that displacement, right? So this is this part A and this part A, they kind of join up in a straight line with about almost a kilometer of displacement, right? 950 plus or minus 100 meters. We can measure the age of the sediments into which that river is cut at about 100,000 years. It's not so important as to the methods we use for the dating. And we can divide one by the other to give us an idea of how fast the fault's moving. It's moving quite rapid. It's 9.1 plus or minus 1.3 millimeters per year. That's actually really fast. That's kind of got a almost plate tectonic scale slip rate. It's probably the fastest fault moving in that whole Iranian region. And yet it's still missing earthquakes. It's still that seismic gap. So let's address the seismic gap here. Let's look at what might be happening in terms of earthquakes. If we go to the field and we look along it, we see this very fresh line all the way along, which kind of looks like an earthquake rupture, right? In fact, it is an earthquake rupture. Again, from the satellite imagery, this is the line, this is the fault, and you can see every single feature in this landscape, little streams, all sorts of things, are all displaced, and they're displaced by smallish amounts, 7 to 8 meters. This is a single earthquake. It's a single earthquake that was probably pretty big. It was probably had a magnitude of about 7.8 estimated based upon the length over which we can map it, the amount of displacement, all of these things. If we excavate through the fault zone, I'm going to show you an image of this, we get an age back from this. It's actually in the medieval period, about 500 to 700 years ago. So this is actually an earthquake that is missing from the historical record. This is just, to show you that earthquake rupture. This is to show you, all of the streams, everything is displaced, right? This is displacement that occurred in an earthquake. And again, right, everything is displaced through here, so it's very clear, including archaeology. There's this remains of unknown age here, and the walls of this settlement here are displaced, or field boundaries, right? There's all these agricultural systems, right, with the fault running through the middle. All the field boundaries are displaced, right? And you can go into the field and you can find these field boundaries, and you can see them at the other side of the fault. So everything is displaced, and seems to have done so in this earthquake, which was about 500, 700 years ago. This is how we know this, right? Here's the fault. We find a place where sediment is accumulating on one side of the fault, right? So things are building up, and we dig a trench across there, and here's our trench. These are the sediments that have built up against the fault, and we can date them, usually using charcoals or other materials, and we can estimate when those sediments have been displaced by earthquakes. And so that's how we can bracket the age of the earthquake in this case to a relatively recent time. And so we find that gap in seismicity is anything but a gap. It tells us that there was actually a really, really big earthquake there not that long ago, and whose remains still lie in the landscape. At a rate of 9 millimeters per year, that 7 to 8 meters of displacement can accumulate in less than 1,000 years, right? So a recurrence interval of something like 800 years. The earthquake there occurred something between 700 and 500 years ago, right? So actually the gap is potentially a place with significant hazard attached to it, right? An earthquake like that will happen again at some point. We don't know when, but it's the faults do seem to fail in this large earthquake behavior. Let's go to Ashgabat, the capital of Turkmenistan. Modern cities, very large. Ashgabat has a proven history of earthquakes. In 1948, there was the big disaster, which killed many inhabitants. It's actually quite unknown as to exactly how many people died at that time. One thing that we've been doing recently is to actually go back to those 20th century earthquake disasters and actually try and understand what happened in them. So using various techniques, taking old paper seismogram records, digitizing them, using seismological techniques to understand the earthquake source, using satellite imagery to map out where earthquake ruptures might have been, using any archive information, again, to give hints as to where ruptures were found or where the greatest shaking was found, and gradually developing an idea of what happened in this earthquake. This was Ashgabat here. The red lines represent places where faults probably ruptured. So, there's some rupturing to the south east. There was some rupturing also to the northwest. So 2 segments and magnitude of 7.3 or something like this. Ashgabat in the middle of it, so very close to the actual epicenter, and in the middle of the so right here is the epicenter, so very close to the city. So that was 1948. But what is also surprising here is if you go to the landscape around Ashgabat, and this is an archaeological site, one of the cities of Nisa, Parthian age city. And you can see a fault scarp running all the way through the middle of this, here, and actually apparently displacing the walls of that city here, right? Okay, that's the fault running through it. It seems as though it's actually been displaced in some way. Likewise, we can find these Ganat tunnels, these underground canals. The fault is running along here. This is displaced, apparently. You see there's a gap in the line. And both of those faults are not ones that are known to have broken in 1948. And indeed, this one, these panels C and D here are within the urban area of Ashgabat now. So there are faults, again, that do not seem to have been related to 1948, but do seem to have showed displacements in older, the last 1,000, 2,000 years. And so, again, some of this detailed knowledge can help us to understand where sources of hazard for the present day and the future may exist. That gives you a run through. We've now, over the last few years, we've been working in Azerbaijan in a collaboration with the National Academy of Sciences, a Republican Seismic Survey. And we've been looking in 2 ways, similar ways to those things I've been showing from Turkmenistan. One is to look at the sources, or to try and establish the sources of large historical earthquakes, but then also to use remote sensing to map where the active faults are, to start trenching them, to understand when earthquakes have occurred and how big those earthquakes may have occurred, recognizing that not everything may be represented in the known historical record. So we've got 2 studies we're going to show you. One is actually from close to Shumaki, along this fault here at Agsu. The second study is actually from the Kura Basin itself, where you seem to have these big strike-slip faults cutting through the landscape. Because they're strike-slip and they move things laterally, they don't make topography, or much topography. The Kura Basin has a lot of sediments deposited within it, lots of agriculture. So these things are actually quite hard to recognize. And yet once you actually start to see them, you can see that there is evidence of active faulting. And indeed, it looks to be relatively important. So here's the Kura Golden Thrust Belt. So, this is Shumaki here. This is the edge of the Caucasus, and then you have what is called the Kura Thrust Belt, which kind of propagates out into the Kura Basin towards Tbilisi in Georgia. And the Shumaki earthquake of 1903, these are the contours of strong shaking from that earthquake. We identified various places along this fold and thrust belt where you can see displacement of the landscape, little steps. These probably represent fault movement, fault scarps, okay, in previous earthquakes. And we identified one place represented by figure 3 here. This is a paper, it's published, Pierce et al. 2024, where we found a small fault scarp cutting across a small river. And we were able to excavate a trench across that. And this is just showing you photographs. This is what we identify as the fault scarp. The trench is excavated across it. Notice that small scarp there is superimposed on a much bigger scarp. So this is like multiple earthquakes over presumably 100,000 years or so in that higher scarp. And when we look at the trench, what does it show us? It suggests to us here that there's been 2 periods of motion represented. Dating was difficult, and yet it's consistent actually with 2 surface displacements within the last few hundred years. So potentially the 1668 very devastating earthquake that occurred in Shamaki, and then the 1902 earthquake as well. So this may well represent the motion in those earthquakes, and would then tell us that actually it's this major fault along the edge of the mountains that was responsible for these earthquakes, which before was a mystery. If we go further along, we have one other trench from closer to Gokchai, I think. And here it seems to suggest a slightly different behavior. A single earthquake, the most recent one, was over 2,000 years ago. So different parts of the fault system behaving differently. So, you know, we can start to build earthquake records in these senses. There's two trenches. We will need to do much more in order to understand how earthquakes have occurred across this zone. This is just saying again that this fault seems to be quite an important fault. It's moving quite rapidly. Therefore, that tells you that, you know, it minimizes the recurrence interval. There's more likely to be more large earthquakes. The faster the fault is moving, the faster it accumulates displacement. If we move to the Kura Basin, or the West Caspian fault in the Kura Basin, we have a number of these kind of what I described as strike slip faults. There's a number of scarps that can be identified from them. Again, and this is a paper that's currently being prepared by a postdoc of mine, Neil Marshall, and there seems to be quite large lateral displacements of, you know, for instance, of this river valley here, and with the dating that we have, suggests quite important faults quite rapidly moving. Trenches through these fault zones suggest a number of earthquakes occurring over a relatively short period of time, several thousands of years. Again, nothing in the historical records, or very little. So that's kind of, you know, where we are with those studies in Azerbaijan, the paleoseismic studies, at least. I think what I wanted to convince you of from those is that by doing this kind of technique, which is quite hard work, right? And you have to go and find the right sites, and you have to excavate trenches, you have to spend a lot of money getting age control and all the rest of it. But they are very valuable ways in terms of developing earthquake records over appropriately long time periods, right? Yes, we can look at instrumental earthquakes recorded over the last 50 years, but they don't tell you everything, right? And if you're looking at the very large earthquakes, those ones that may cause extreme damage to town, cities, infrastructure, you need to look further back in time to really see what level of earthquake, what type of earthquake might occur. We have tried to focus on sources of known historical earthquakes to start off with, you know, and from there to branch out into other unknown or less well mapped areas. It's also, you know, it's also important to know how important each of those faults are, right? So that tells you something about how often earthquakes may occur on average. And it also tells you how these faults accommodate the overall tectonics, right? The more geological aims. So that's where we are. We've looked at those two big fault zones. There's still work to do. I know that, you know, we'll be hearing, we just talked about Azerbaijan for that second part, but that fold and thrust belt actually extends all the way across Georgia as well. And it's going to be very important. We're talking about kind of cross-border hazards, that this is very much so something that crosses the border. Any study that we have from Azerbaijan can help inform Georgia, and likewise in Georgia, it can help inform Azerbaijan. And we also, you know, within there, we have large cities, which require a lot of work in order to try and understand what the past records of earthquakes may be for those places. We also have a lot of infrastructure, transport networks, energy networks, all of these things. So all of this kind of really demands a a long knowledge, right, from these kind of geological techniques to try and understand exactly what the present day levels of hazards may be for all of those. Thank you for your attention.
Fabulous. Thank you so much, Richard. That was a really, really interesting kind of snapshot into what you've been doing in Turkmenistan and Azerbaijan. And we'll have time for questions at the end, but I think we'll just hand directly over to Nina for now to hear what she's been doing at Sustainable Caucasus.
Okay, probably, Richard's presentation leaded me a little bit to another direction. So probably he mentioned that there is informational gap about the earthquakes in the Caucasus specifically. And as an idea, probably it's because in the 12th century, we know, for example, that in Georgia, the huge earthquake happened in the southern Georgia, close to border of Armenia and Turkey. But we don't know from the historical sources how this earthquake affected rural population, let me say. So probably the written historical records been more focused on the damages than on the things which were not affected, let me say. And in Georgia, to explain, and in Armenia as well, in the meantime, Azerbaijan has a little bit different history. But in these two countries, definitely, the historical knowledge where to build and how to build was also very, very much important. So I'd like to speak a little bit about the other types of the hazards, which is about the mud flows and the other climate change and use hazards. So let me show you a few slides which I prepared time ago for a meeting in Carpathians in the meantime. So I'd like to tell you a story about the Shovi hazard, which happened very recently in Georgia, and it took life of a lot of people. For Georgia, it was a lot. This resort, where it happened, started to be developed in the Soviet Union back in the 1928. And it was very popular destination during the Soviet planned economy because not only the Georgians been visiting this place, but the other the people from the other republics, and this place is located in a close to the riverbed of one of the rivers in the mountain Raja. And in the Soviet Union, somehow, probably due to the better knowledge, I don't know, but the most of the touristic infrastructure was located at the edge of the valleys, closer to the foot of the mountains. So that's how it's looked. But historically, starting from the 4th, 6th century, in this gorge, so here is Shovi, if you can see it, these 4 points, see? Nothing was constructed. This was constructed only in the Soviet era. While the main village of Glola was constructed here, you can see this red square here, and it was constructed on the right embankment of the river, which is more mountainous, let's say. And in the Soviet period, the GLOLA started to be developed on the left embankment, which is much more affected by the mud flows. So what I'm trying to say that probably the historical knowledge is important while we are talking specifically on such a things like climate change, for which 100 years is nothing, and then probably the 300 years is nothing as well. But when we are talking about the 1,000 years or more, that might be taken into account. So speaking about the earthquakes, probably our ancestors were not constructing the infrastructure, the cities specifically, or villages in the areas which been more affected by the earthquakes. Further, quite recently, like probably a few years ago, our government decided to develop Shovi resort more, and you can see on the central slide that right in the riverbed, they decided to construct this huge hotel, and some of these infrastructural buildings started to being constructed, and that you can see on the left side, left picture. And the big festivals are being organized there. And before this Shovi hazard, which happened in August of the last year, the huge festival was organized. Lucky those people who managed to leave it, and there were much less people there when the hazard happened. But that's how the place looked like after this hazard happened. So you can see, and about 40 people life of the 40 people being lost during this in this event. Sorry. So the problem of the Shovi resort was that the SEA and EIA, which the constructing company elaborated, was not mentioning this important historical events which been happening in this area at all, not during the Soviet times, not before that. And of course, we do think that the scientific organizations should be much closely involved in the research of the things before any recommendations from the experts should come up. And the main expertise comes probably, from the National Environmental Agency, which unfortunately didn't pay sufficient attention to the results of this environmental impact assessment, which was elaborated for the resort. And here you can see again the map, which shows that the Shovi here, the second red square here, it was known by the environmental agency that it's affected by the mud flows generally. But at the end of the day, with the help from our network colleagues and the international colleagues, it was later on clarified that it was not just the regular mat flow, which was recorded before, but that was glacial lake outburst flood, GLOFs. And currently our colleagues are preparing the article, which we will be happy to share with you. But unfortunately, not in the National Environmental Agency and not in the scientific institutions. We do have in Georgia the information, even the satellite imagery, which you can see, was not available to make a prediction. So, and overall, the monitoring of the glaciers are not that well organized in Georgia, which is, frankly speaking, it's a shame. So shall I? The facts which been disregarded, I already mentioned that all rivers around Shovi continuously are reported as a mud flows affected. Shovi originally recorded as a high-risk area. Glacier monitoring is not implemented neither remotely nor on spot. Resort development plans lack of detailed clarifications on hazard. So that particular part was, if you will ask me, completely missing. Setup of the natural hazards monitoring, assessment, and mapping needs urgent reform in Georgia. And the cooperation between the scientific and the governmental agencies should be much more regular and much more closer, let me say. So that's what I wanted to tell you. If I yet have a few minutes, I can speak a little bit about our scientific network, which works across the 3 countries of the Caucasus, and even in these complicated geopolitical situations, trying to cover more like Iran and Turkey and Russia as well.
That would be great, Nina. I think we have about 5 more minutes, but we'd love to hear more about the network, though. Thank you.
Okay, then I will. Then I will probably say a few words about the most important things which I think might be interesting for you. So, and not to take too much time. So this is our region. So the main, of course, focus is on Georgia, Armenia, Azerbaijan, but we are somehow covering the Russian Federation and somehow covering Iran and Turkey. And this is the structure of our organization. So we have a scientific network, which represents the 6 countries. We do have a secretariat of Sustainable Caucasus, which is a Sustainable Caucasus. We have a Caucasus Spatial Data Infrastructure Group, and the 3 initiative groups, which we in the future do hope, if everything will work fine, extend to Turkey, because it's impossible to work in Russia and Iran, unfortunately, under the current situation. Our objective is to foster the sustainable development in the Caucasus Mountain region and to elaborate the regional approaches to transboundary problem solving at the national and local levels. And maybe I should mention also that after the Spitak earthquake in Armenia, the earthquake network between Georgia, Armenia, and Azerbaijan is rather strong, and they are exchanging the information on a regular basis between themselves, but that is a topic which probably our colleagues from Ilia State University should cover. And some of them recently been in Oxford as well. So we are members of a covenant, supporters of a covenant of mayors, members of the network of European Mountain Research, NEMOR, the members of the steering committee on the strengthening climate change adaptation capacities in Georgia, which is GCF project implemented by UNDP. Member of the UN Mountain Partnership. Our main partners are UN Environmental Program. Main partner, scientific partner is University of Geneva, Mountain Research Initiative. I think I miss Science for Carpathians, of course. UN GRID Geneva, UN GRID Arendal, WWF Caucasus, which is out of question, no surprise, and Jagiellonian University in Poland. Our kind of a Bible to work in the Caucasus is the Caucasus Regional Research Agenda, which was approved back in 2019. In Ankara at the Caucasus Mountain Forum. It covers 10 topics beside the cross-cutting ones, and natural hazards and risks are one of them. Recently, not recently, but a year ago, we made an assessment of the progress of implementation of the regional research agenda, which is not easy, from collecting the sources from the Google Scholar and the Scopus and the other reliable information sources, mostly English language published works. And you can see that we don't have too many regional articles, let me say, cooperative articles. And cooperative articles, I mean more than 2 countries. This is assessment of the natural hazards publications, let me say, and you can see that the most active country in this term, and probably because of the earthquakes as well, it's Armenia, and it builds up about half of the all articles in the region. So this is the web page of the scientific network. And we are very proud of this resources section, which we consider as the biggest probably hub about the sustainable development information about the Caucasus region, which keeps more than 5,000 publications and about 2,000 scientists. And we do have 500 self-registered scientists who we do consider as members, officially members of the scientific network. The main meeting place is a Caucasus Mountain Forum for the Caucasus scientists, and the last one was in Kutaisi, and before that in Ankara. Another one was in Tbilisi, and we do hope that we will manage to organize the 4th Mountain Forum, which is a traditional in Turkey, but we don't know so far where it will take place. Because in reality, we do have only 2 countries currently where all the countries can meet. It's Georgia and Turkey. So these geopolitical things are influencing the work of the network and the secretariat very much as well. We mentioned that the region, the national initiative groups in Armenia, Azerbaijan, and Georgia, which gathers like about probably 20-25 scientists and non-governmental organizations and the practitioners. Practitioners, I mean, from the business sector mostly, to exchange, to cooperate, to advocate the different topics and different issues. And some of them are, I don't know, some of them are sometimes natural hazards, but many other aspects as well. At the regional level, the main focus is on the climate change. And the regional initiative group built based on this national initiative groups issued this two policy briefs, hoping that it will be implemented. And we are currently in the process of looking for the methods of implementation of these recommendations from this group of scientists and practitioners. Probably, yeah, I will skip this slide. This is our SDI team. We are very proud of it. On the SDI platform, you can find whatever available free of charge maps in the GIS format, which is, I guess, very useful tool for those interested in the environmental sciences of the Caucasus. And another important achievement, which will finally take place this year, will be the second Caucasus environmental outlook, which will cover 6 countries: Armenia, Azerbaijan, Georgia, Iran, Russian Federation, and Turkey. We are very much looking forward, and probably you are the first one in public who see the cover of the publication. In a few months, finally, it will see the light. This is about the methods, how we are worked, let's say. So now it's in the editorial process only. It was drivers, pressure, state, impact, and responses. That way we structured all the chapters. And you can see that in the drivers chapters, it's a population, it's climate change, it's economy, and urbanization, the drivers of environmental change. And then we have the 4 main chapters and the land cover, which was very unique because we made an analysis of the land cover based, of course, on the satellite imagery. But that's why I'm saying it's a unique work, because all the countries are doing their research in with a different methodology, and it's hard to find the comparable information. Yeah, it covers, as I mentioned, 6 countries, existing situation, trends of development, and forthcoming challenges. And this is a level of urbanization of the Caucasus map. On the natural hazards, we are very actively working with higher education institutions, trying to introduce the similar methods in the education. We also do have regularly are organizing the summer schools, and one of which, Ainsley, took part in Ozurgeti, and the last one. These methods, which we elaborated together with the University of Geneva, now are used by quite a lot of higher education institutions in all the 3 countries. So you can see the list here, and a number of students during the last 2 years who passed the course under the different programs, both bachelor and the master. It's about 300. And this is a regional knowledge hub where you can find all these methods and the tools and instruments, which is hosted by Ilia State University. So I will not take more time of yours because the other things are more focused on the more practical things throughout, again, quite also focused on the climate change and the hazards as well.
Thank you so much, Nina. That was really fabulous. Great to hear about the work that Sustainable Caucasus is doing, and it's really, really impressive. And so great to hear a little bit about that, as well as the case study of Shovi as well. Thank you for kind of giving us an overview of what happened there. I'll stop the recording, and I want to open the floor